Hello everyone, this is DS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is minimum number of steps to make two-string anagram. So let's jump into the problem statement. You are given two strings of same length S and T. In one step you can choose any character of T and replace it with another character. Return the minimum number of steps to make T an anagram of S. What is an anagram? An anagram of a string is a string that contains the same characters with a different or the same ordering. Okay, so this was the problem statement. Now, after reading this problem statement, I understand something like this, that looking at this example, I'll be given a string S and string T. Both S and T would have the same length. Okay, and I want to make sure that whatever alphabets are present in my string T are equal to whatever they are present in my string S. The ordering can be different. Okay, so when we talk about this, we understand one thing, that what needs to be similar. If ordering can be different, then what should be similar? We need that the number of occurrences of each alphabet which is present in S should be equal to the number of occurrences of the alphabet in the string T. I hope this is clear from the problem statement. So now, after understanding the problem statement, this is a very easy question, though it has been tagged as medium, but it is a very easy question. Let's talk about the approach. When we talk about the approach, I understand one thing, that what I want to do is I want to somehow convert T into S, right? And I want to do that by having minimum number of steps. And for that conversion, always remember, we do not have to replicate the string. We do not have to do that. We do not need to replicate it. We just need the number of occurrences for both of the strings alphabets to be equal. That is what we want. So if I look at this example, which says S string is BAB and T string is ABA. So I understand that number of occurrences. I'll quickly write it down here so that it is easier. I understand that S is BAB and T is ABA. So if I look at S, because I have to convert T into S, right? So, and T into S, not the replication, what? The number of occurrences need to be same for each alphabet. So let's figure out the frequency corresponding to each alphabet. So in the case of string S, we have A once, we have B twice. Talking about the string T that we have alphabet A has a frequency of 2 and alphabet B has a frequency of 1. So we see there is a mismatch, right? If you compare these two, there is a mismatch. So how can I convert this is, if I could have had one more B rather than having a A, right? So we can simply use this approach for solving the question. Now let's talk about how will we implement this approach. For implementing this approach, what we can do is we can simply use something like a unordered map data structure in which I'll be storing the character and its corresponding frequency, right? So I'll be storing the alphabet of string S and I'll be storing its corresponding frequency. And what I can do is, after storing this, what I'll do is I'll simply iterate over the T string and I'll compute the difference, that how many of the occurrences of that particular alphabet are not there. And we need to then, after that, we know that, okay, these many occurrences are not present, right? So this is the number of changes that are required. So if we talk about this example, the answer would be 1. I hope it is clear. It is completely based upon the concept of hash maps, right? So now let's quickly use another example and see the pseudocode, and then we'll move forward with the actual implementation through coding. I'll also have a dry run here for this problem. Okay, so here as you can see, I've been given S as lead code and I've been given T as practice. And we know that I need to convert T into S, and by conversion we mean the number of alphabets should be equal in both the cases, string S and string T. And the ordering does not matter, right? It does not mean that I need to get this whole word here. I just simply want that if L is present only once in string S, it should be present only once in my string T. Okay, so I told you what will be the first step. The first step would be to add all the alphabets with their frequencies in my map data structure. So I'll create a map data structure, and what I'll do is I'll have this mapping there, alphabet and frequency. So let's start from here. We'll say L, it is present once. E, we'll come here. So we'll say it is present once. Then we come here, we see, okay, it is again present. Increment the frequency to 2. We'll move our pointer. We'll say T, it is present once. We'll go to C, it is present once. O is present once. D is present once. And then we come to E again. So we'll say increment the frequency to 3. So we've understood that this is what I have in my string S, and I want the similar structure in a different ordering in my string T. So now what I'll do is I'll simply use a for loop and I'll say, okay, now you have to iterate over each of the alphabets that is present in my string T. Okay, so this is the indexes corresponding to my string. I have a string T of 8 length, and that is also what is the length of the string S. So what I'll say is, I'll say, okay, let's see if it is present here, right, or not. So I can simply use dot find function of map, in which I'll say if it is present, in that case, reduce the corresponding frequency to it. Okay. So what I'll say is that use dot erase function of the map to, sorry, and so if it is present, so what I'll do is, if it is present, then I'll say, okay, decrement its frequency. So for decrementing its frequency, I'll simply say that whatever is corresponding to this in my map, decrease the frequency by 1. So it will say P. P is not there in the map. So for that, we can simply have a count variable, which will be keeping track of how many different words are there in string T, which can be easily replaced, right? So I'll say, okay, uh, this is if found, right? And else if we have not found it, that m dot find is equals to m dot end. So in that case, just increment the count. So here my count will become 1. Then I'll go to R. We'll again check that if m dot find, is it present in my map? It will say no, it is not present. We'll increment the count to 2. Then we go to the second index, which is storing A. A is not present in my map data structure, so we'll increment the count to 3. We'll go to C now, and we see that yes, C is present in my data structure here. So what I'll do is, I'll simply decrement its count to 0 because it was 1. So it becomes, we'll decrement it by 1, so we'll get 0. And we can add this condition that if at any point of time, if m of t of I becomes 0, in that case, simply erase that value from my map because I do not need it anymore, right? There is no frequency count corresponding to it. Why is it important is because see, you look at this, you'll understand this when we'll complete this example and we'll come to this second occurrence of C in the string T. That is when you'll know why did I do this. So let's move forward. I come to index 4 and on index 4 I have T. So here I see that yes, T is present in my map here. So what I'll do is I'll decrement its count. Its count again gets decremented by 1, becomes 0. We erase it from the map. First we have erased. Okay. So first we are decrementing the frequency, then we are checking if it is equal to 0. If it is, then just simply erase it from the map. Now we no longer have any alphabet T or C in our map M. Next we move to fifth index. We see we have I. I is not present in my map. I'll simply increment my count to 4. We move to the next index. Now we get a C. Earlier, if we had not removed it from the map, we would still have had a entry corresponding to C. But now we do not have any entry corresponding to C. So in that case, my count gets incremented to 5. Now I'll move forward. I come to the seventh index. I'll say E. It will say, yes, I have E. We'll simply decrement the count. It becomes 2. As it is not equal to 0, E will not be erased, right? So we understand that we need to change 5 places so that, and those 5 places can have the elements that we have in string S in any order. What matters to us is the count only. Okay. So we'll simply return the count. I hope this was clear. Now I'll quickly switch and let's code this up. Okay, so this is the problem that we have. I'll quickly take an unordered map, which will be storing my alphabet and its corresponding frequency. What I'll do is I'll simply run a loop over the first string, that is S, to which I want my T string to be converted into. And by conversion, I just want that the number of frequency of the alphabets in both the strings should be equal. The ordering does not matter. So I'll simply add these elements here so that I get a mapping of the alphabet and the frequency for string S. Now I'll simply run another loop over the second string, that is T. And here, what I'll do is I'll simply check if it is present or not in my map. And for that, I can use the m.find function. So I'll say if it is not present, okay, that you have reached the end. So in that case, here we can initialize a count variable to 0. I'll say that it is not present in my map. That means it is that alphabet has no occurrence in my string S, right? So in that case, increment the count. Else, if it is present, what you will do is you will decrement the frequency value corresponding to that alphabet in my map. And if at any time this becomes 0, right, in that case, just erase that element from my map. And then we'll simply return the count as the answer. I hope this is clear and this shall work. Let's run this. Okay, let's submit it. And yes, it is working fine. Now let's quickly discuss the time and the space complexity for this. Okay. Okay, so this is the code that we have used. First, let's talk about the time complexity. Here we can see that I'm running 2 loops. The first one here and the second one here. The first one is run for O of n, where n is the length of string S. Because I'm iterating over all the elements which are present in my string S and I'm putting them into a data structure, right? So it is O of n. Now here again, the time complexity is O of n. Why? Because in the starting, we saw in the problem statement that the length of S is equal to the length of string T. Therefore, even here, what I'm doing is I'm iterating over all the alphabets in my string T. I am checking if it is there or not in my unordered map which I created here, and then I am doing the processing. The m dot find function takes just O of one time. Okay, so the time complexity as a whole becomes O of n plus O of n, which is again equal to 2 of n, which is just similar to O of n. Talking about the space complexity, as I am storing n characters, right? That is the length of the string s in my map. So the space complexity becomes O of n. Therefore, I can say for this problem statement, the time complexity is O of n and the space complexity is again O of n. Thank you for viewing the video till the end. Please like, share and subscribe.